The first samples from the far side of the moon have reached Earth. The return capsule of China's Chang'e 6 probe delivered the first samples of material from the far side of the moon to Earth. The precious cargo landed safely by parachute on the steppes of Inner Mongolia. This is a landmark achievement of China's space program. The re-entry module successfully touched down in a designated zone in the northern part of Inner Mongolia just after 2 p.m. local time. The landing was broadcast live on CCTV. Cameras showed the module landing by parachute, and moments later an employee carrying out inspections of the equipment, which was lying on a grassy area next to a Chinese flag. Chang'e SIX's lunar exploration mission was a complete success, said Zhang Kejian, head of the China National Space Agency, CNSA. The delivery of lunar material samples to Earth concludes the highly successful CNSA mission. Chang'e 6, named after the Chinese goddess of the moon, launched on May 3rd. She landed on the silver globe on June 2nd. It settled on the side invisible from Earth, in the Apollo crater in the area of the South Pole Aitken Impact Basin. It is the largest known impact structure in the entire solar system and the oldest on the moon. For 2 days, the mission's lander collected samples of rocks and regolith, the lunar soil, using a robotic arm to take samples from around the lander and a drill to reach material up to 2 meters below the lunar surface. Then the ascent module with tightly packed samples reached the orbiter, from where it set off on its return journey to Earth. This is a great achievement for China, said Martin Barstow of the University of Leicester. Collecting samples from the moon is difficult, but doing it on the far side, where communication is especially difficult, is an achievement that no other space agency can boast. This is a real technological feat, he added. Operations conducted on the far side require a communications satellite to act as a relay station for communication between the lander and Earth. This role is fulfilled by the Queqiao 2 satellite, launched in March, which is equipped with an over 4-meter antenna. China is the first country to bring material from the far side of the moon to Earth. Previously, various missions from the United States, the Soviet Union and China had delivered samples of material from the side visible from Earth to the planet. The Chang'e 6 mission planned to collect up to 2 kilograms of rocks and regolith. The new samples could shed light on the early history of our natural satellite. Accurate dating of the South Pole Aitken Basin would provide a time frame for the collision that created the massive impact structure. What's more, the impact could have ejected enough rock to expose areas of the lunar mantle, which scientists say is key to understanding the history of the silver globe and potentially its origins. Perhaps fragments of the mantle will be found in the collected samples. Material from the far side of the moon may also tell us something more about the formation of craters there. Understanding the rate at which large asteroids struck the moon in its early history would shed light on Earth's impact history, as our planet was exposed to bombardment by the same asteroids. This also has consequences for the emergence of life on Earth. Analyzing the composition and physical properties of the samples may also help develop methods for using the moon's resources for future exploration. The far side of the moon is geologically different from the visible side. It has fewer ancient lava plains and a thicker crust, and because it is not shielded by Earth, it has more impact craters. Sampling the unseen side is incredibly exciting scientifically because we only have very limited information about the geology there, Barstow said. It was processed completely differently than the side of the moon facing us, which in the past underwent thorough renewal by volcanic activity, he added. We are entering a new era of discovery, and obtaining samples from the far side of the moon is a milestone that will help us understand the geological history of this region and why it differs so markedly from the more famous visible side. Specialized laboratories around the world have spent 5 decades refining analytical techniques to extract the moon's secrets from samples taken from the visible side during the Apollo and Luna missions. And now we are on the cusp of applying all this knowledge to learn more about the mysterious invisible side of our closest neighbor in space, said Simeon Barber of the Open University. Robot face with specially designed skin made of human cells. Japanese scientists have developed extremely realistic skin for robots. The engineered tissue is composed of laboratory-grown human skin cells and contains the equivalent of ligaments to hold it in position. It can also repair itself, much like human skin heals. A living skin model composed of cells, extracellular matrix, and silicone has the potential to become an ideal material for covering robots, making them more realistic. The tissue was developed by a team of scientists led by Professor Shoji Takeuchi from the University of Tokyo. This is not their first work on realistic coatings for robots. 2 years ago, the same team developed a substance consisting of human skin cells, which they covered a remotely controlled robotic finger. Drawing inspiration from the ligaments of human skin, scientists also found a way to connect the designed skin tissue with the robot's skeleton. This research may be useful to the cosmetics industry and help in the training of plastic surgeons. The description and results of the research were published in the journal Cell Reports Physical Science. The developed living tissue is a mixture of human skin cells grown in a collagen scaffold and placed on top of a 3D printed resin that acts as a skeleton. Unlike previous similar experiments, the skin also contains the equivalent of ligaments, called perforation-type anchors by the researchers. Perforations made on the robot's face allow the skin layer to anchor and stabilize, which helps keep the robot's skin in place while maintaining a smooth and flexible surface. A technique of attaching skin made of living human cells to a robot's skeleton could give robots the ability to express emotions. This could lead to better, more realistic communication, which in turn could change attitudes towards humanoid robots covered in it and make them indistinguishable from humans at first glance. During previous research on a finger-shaped robot covered with modified skin tissue that we grew in our lab, I felt that the adhesion between the skin-structured robot needed to be improved, Takeuchi said. By imitating the structures of human skin and ligaments and using specially made V-shaped perforations in solid materials, we have found a way to bond skin to complex structures. The skin's natural elasticity and good adhesion mean the skin can move with the robot's mechanical components without tearing or peeling off, he added. Scientists checked how their skin behaves. They combined the developed shell with the robot's face. They placed a thin layer of silicone between the skin and the skeleton, which allows the living tissue to glide, and recreated the way the skin changes when a person smiles. Thanks to the new mounting method, the skin could easily fit the three-dimensional face model, without any protruding screws or hooks. Previous methods of attaching skin tissue to solid surfaces included miniature anchors or hooks, but these limited the types of surfaces they could be attached to and could cause damage during movement. A new method of attaching the coating using tiny perforations made in the base material makes it possible to apply leather to any shape. Scientists also used a special collagen gel for adhesion, which is naturally sticky. They managed to force it into tiny perforations. Manipulating soft, moist biological tissues during the development process is much more difficult than it might seem to those outside the field. For example, if sterility is not maintained, bacteria can enter and the tissue will die. But now that we can do it, living skin could provide robots with a range of new abilities. Self-repair is a big deal. Some synthetic materials can be induced to repair themselves, but they require triggers such as heat or pressure and do not reproduce like cells. Biological skin repairs minor cuts just like ours, Takeuchi said. The skin developed by the team can be used in several areas of medical research. The invention could be useful in skin aging research, cosmetics, surgical procedures, plastic surgery, and more. In addition, various sensors can be embedded in the coating, which will give it new capabilities. Through this research, we have identified new challenges, such as the need for surface wrinkles and thicker epidermis to achieve a more human appearance. We believe that creating thicker and more realistic skin can be achieved by incorporating sweat glands, sebaceous glands, pores, blood vessels, fat and nerves. Of course, movement is also a key factor, so another major challenge is to create human facial expressions by integrating sophisticated actuators, which act as muscles, inside the robot. Creating robots whose shells can repair themselves, sense their surroundings more accurately and perform tasks with human dexterity is incredibly motivating, admitted Takeuchi. However, robots with such skin are the melody of the future. Scientists still have a lot of work ahead of them. Firstly, we need to increase the durability and longevity of cultured leather, in particular by addressing issues related to the supply of nutrients and moisture. This may include the development of integrated blood vessels or other systems. Secondly, it is crucial to improve the mechanical strength of the leather to match that of natural human skin. This involves optimizing the structure of collagen and its concentration in the cultured skin, noted Takeuchi. Takeuchi also noted that to be truly functional, such skin will eventually need to transmit sensory information such as temperature and touch to any robot wearing it, as well as be resistant to biological contaminants. Forever chemicals can penetrate the skin and enter the bloodstream. Recent research suggests that the so-called forever chemicals can be easily absorbed through the skin. This allows a wide range of toxic substances known as PFAS to enter the bloodstream. This raises safety questions because many everyday products contain forever chemicals. Forever chemicals or PFAS are per- and polyfluoroalkyl substances. They are widely used in industry and everyday products, for example in food packaging, waterproof clothing and cosmetics, due to their hydrophobic properties. Unfortunately, the rate of their decomposition is extremely slow, which is why they are called eternal. These chemicals can be found in seas and oceans, in soil, and rivers. They spread throughout the world in the atmosphere, and as a result, they can be found in rainwater and snow even in the most remote places on Earth. A 2022 study found that rainwater in most places on Earth contains levels of forever chemicals that far exceed acceptable safety standards. Forever chemicals also enter our bodies. We inhale them with the air or consume them with food or water. Most people have detectable levels of them in their own blood. While some PFAS substances have been banned, others are still widely used. However, their toxic effects have not yet been fully investigated. They are known to cause adverse health effects such as decreased immune response, impaired liver function, increased blood pressure, reproductive problems, and increased risk of cancer. These compounds can lead to changes in biological processes associated with a wide range of diseases. In a recent study, scientists found that these dangerous chemicals can penetrate the skin and enter the bloodstream. The description and results of the research were published in the journal Environment International. The new study is the most comprehensive assessment of PFAS absorption by human skin ever conducted. They confirm that most of the forever chemicals can enter the body this way. The possibility of absorption of these chemicals through the skin was previously rejected because their molecules are ionized. It was believed that the electrical charge that gave them the ability to repel water and stains also prevented them from penetrating the skin membrane. Our research shows that this theory is not always true and that, in fact, skin absorption can be a significant source of exposure to these harmful chemicals, said Dr. Oddny Ragnarsdottir from the University of Birmingham, lead author of the study. The team examined 17 different PFAS in their analyses. Scientists chose specific compounds for study because of their popularity. The selected chemicals were among those most frequently used in industry and most widely studied for their toxic effects. Scientists tested PFAS uptake on three-dimensional models of human skin, multi-layered, laboratory-grown tissues that mimic the properties of normal skin. Skin models were treated with samples of each of the 17 substances and measured how much of the sample was absorbed and how much was stuck in the tissues. Experimental results showed that of the 17 PFAS tested, 15 showed significant dermal absorption at least 5%. Doses. But the absorption into the bloodstream of the PFAS PFOA, perfluorooctanoic acid, was 13.5%, and another 38%. Dose remained on the skin and could potentially also be absorbed later. The amount absorbed through the skin seemed to correlate with the molecular structure of the compounds. Substances with longer carbon chains showed lower absorption levels, while compounds with shorter chains, such as PFOA, were more easily absorbed. Our study provides the first information on the importance of the dermal route as a pathway for exposure to a wide range of forever chemicals. Given the large number of PFAS in existence, it is important that future research aims to assess the risk of a broad range of these toxic compounds rather than focusing on just one, said Dr. Mohammed Abdallah, co-author of the study. This study helps us understand how important skin exposure to these chemicals may be, as well as which structures may be most easily absorbed. This is important because we see a shift in the industry towards shorter chain chemicals as they are thought to be less toxic, but the effect of this may be that we absorb more of them, so we need to know more about the risks involved, the professor explained. Stuart Harrod, who also co-authored the publication,